Alright, next up is example 7 for day 18 of the Algebra 2 notes. So it has 3 parts to it. It says write each expression in simplest form. Assume that all variables are positive. Alright, so here's where it gets a little bit weird, because now we're going to have very high powers and very weird radicals. And we're going to need to be able to solve for those. So just like in our previous examples, we want to make sure that we manipulate this inside part so that it only contains perfect fifth powers. Anything that contains a perfect fifth power, we are able to solve very nicely. And so, what do I mean by that? Well, I'm going to rewrite this so that it looks a little bit weird. It's going to look like this, 4. Now, a to the 8th, I can actually write this as a to the 5th times a to the 3rd, thanks to my exponent properties. And then b to the 14th, I'm going to do something similar. I'm going to do b to the 10th times b to the 4th. And then c to the 5 is already where I need it to be, so I'm going to leave it like that. Alright, so this right here, this allows me to take this, and this, because all of those have a perfect fifth root. So what do I mean by that? Let's see. This is going to be the fifth root of a to the 5th. And then times b to the 10th, we have to remember that that is the same thing as b squared to the 5th. And then c to the 5th. And so that's one part of my radical. The other part of my radical is whatever was left over, I write it in there. So it's that 4, it's that a cubed, and then it's that b to the 4th power. Like that. And so now that we are here, now we can take a fifth root of all of these things and they'll simplify very nicely. The fifth root of a to the 5th power is just a. The fifth root of b squared to the 5th power is b squared. And the fifth root of c to the 5th is just c. And so all we have to do now is multiply that by this, and this cannot be simplified anymore, so we are actually finished. Our most simplified answer is going to be a times b squared times c times the fifth root of this inside part right there. So again, it looks a little bit messy, but once you get the hang of what we need to do, hopefully it should seem a little bit easier. So part B, we're still gonna simplify, but again, now we're at the point where we don't like having a radical at the denominator of our fraction. And so what we want to do is we somehow want to get it so that we multiply. We're gonna multiply this fraction by something over something, and that should give me a perfect cube. Whatever's down here needs to be a perfect cube. So what is that number? What do I need to multiply that to make it a perfect cube? I'm going to do that down here. So I'm going to rewrite this. X cubic root of y to the 8th. And now if this inside part was y to the 9th, that would be very convenient. And so because I want that to be a y to the 9th, that's what I'm going to aim for. And so if I want to make this into a y to the 9th, I need to multiply this by cube root of y. And because I don't want to change the actual value of this expression, this is what I like to call in lecture the magic 1, right? If we multiply by 1, we don't change anything, but its form. The only thing we're changing is this form. So on the numerator, we have x times that radical is just x times radical cube root of y. We're going to divide that by the cube root of y to the 8th times the cube root of y to the 1st is actually the same thing as the cubic root of y to the 9th. And we wanted that because we know that the cubic root of y to the 9 has to be y cubed. And now that we don't have a radical in our denominator of a fraction, we are done simplifying, and this right there is the simplified version of this. So again, kind of messy, but hopefully you'll bear with it and you'll practice enough so that it's not super bad. And then part C, last but not least, we have to make sure we get rid of any negative exponent we have and combine all of my x's and all of my y's and etc, etc. So let's see how that's going to look like. So we have that 14 times x. Okay, so this x right here, we can pretend that it has a 1 exponent right there. Now, let me see. Let me think about this one. Okay, cool. So once we establish that, we're going to say that this is actually equal to, and we're going to start taking this apart. 14 divided by 2 times x to the 1 divided by x to the 3/4 times, there is no y downstairs, so I'm just going to do y to the 1/3 over 1. And then likewise on the other one, there is no c to the negative 6 up there, so we're just going to do 1 over z to the negative 6. So notice how I'm just taking my multiplication apart, right? I'm not really doing anything, and if I wanted to, I can multiply all of these and end up right back here again. But the reason I did this is so that we can start solving and simplifying any exponents that we might have. First thing we can simplify is this right here. 14 divided by 2 is 7. And now if we remember our Algebra 1 rules, if I want to make sure that I combine my powers here, I have to do the opposite of my exponent quotient one, which tells me I should subtract a 3/4 from 1. Alright, so 1 minus 3/4 is actually going to give me 1/4. So we're going to get that x now has a 1/4 power, like that. And then y to the 1/3, well, that one's already positive and there are no more y's, so I'm just going to leave that right there. 1/3. And then we're going to multiply this times z to the negative 6. Z to the negative 6. But again, we do not like the fact that we have negative exponents down here. So if I want to make sure that this turns into a positive, I have to take this z to the negative 6 power and then just send it up in my numerator. And so that is going to give us our final answer, which is 7 x to the 1/4 power y to the 1/3 power and z to the positive 6 power.